Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to discuss on indole. You know, indole is a cyclic compounds benzopyrrole. So let us start learning of structural properties of preparations of properties of and uses of indole. So first properties I am going to discuss here is aromaticity. Before that, you should know the structure of indole, which is known as 1H benzo-B-pyrrole. What is meaning of this B? This B represents the bond which is fused, means pyrrole and benzene. So 1H represents the nitrogen hydrogens, benzo represents the benzene, B represents the fused to ring situation and position, and pyrrole is another heterocyclic compound. So there is 2-3 name. First name is indole, which is very common. 2,3-benzopyrrole. This is replacement nomenclature, and 1H benzo-B-pyrrole, hence vitamin nomenclature. So my friends, always remember the positions 1 goes to nitrogen, which contains hydrogens. This is the concept of numbering of aromatic compounds like indole. So position 1, position 2 goes to carbon, position 3 goes to third carbon, 4th, 5, 6, 7. What is missing here? You can look it out. Yes, fused carbon. Fused carbon is not you numbering it. You will escape it. Their numbering is different. That's why fused to carbon, there is no numbering scheme here. Now, each atom is sp2 hybridized. You are agree with me. And it's plain. The total number of delocalized electrons are 10, 8 of 8 carbon and 2 from nitrogen. Follows the Haskell. And very weak base. Very weak base. Now, my friend, as usual, first you have to look the synthesis. Fischer-Indole synthesis, well-known synthesis. I am going to discuss some important point related to Fischer-Indole synthesis. First, acid catalyzed rearrangements of an aryl hydrogens to indole with the elimination of ammonia. Look at here. And then reactions can be carried out simply by heating together the aldehyde or ketones and aryl hydrogens. Then formations of aryl hydrogens and its subsequent rearrangement take place to give indole. Zinc chloride is used as catalyst. Now everything is clear to you. Look at here the structure of phenyl hydrazine. You look at here the structure of ketones, dehydration occurs, carbon nitrogen bond formed, and phenyl hydrogens. You know very well about the formation of phenyl hydrogen with the phenyl hydrazine. And then you can see all zinc chloride, which is act as a catalyst here, and then cyclization occurs and forming disubstituted indole. What is the mechanism? Now look at here. Step by step, you have to write it down in your notebook. Don't escape it. How hydrogens arrange. Then in hydrazine. What does it mean in hydrazines? Think about that. And then process of cyclization, and that is the 3,3 sigma tropic rearrangement. You know the pericyclic reactions. Here 3,3 sigma tropic rearrangements, and then double imine you can see the further steps, nitrogens forming nitrogen carbon bonds and cyclization occurs. Then cyclic intermediate, then further removal of ammonia, formation of double bonds, and then you can see the disubstituted pyrrole. My friends, Fischer-Indole synthesis mechanisms. A reversible rearrangement of hydrazone to give the reactive in hydrazine. This is very important. You should write it down. A reversible rearrangement of hydrozones to give the reactive in hydrazine. Protonations produce protonated in hydrazines. 3,3 sigma tropic rearrangement in reactions. This is also very important for NET examinations. Formations of a new carbon-carbon bond. Diimine and loss of aromaticity. Now, next important things, re-aromatizations of aryl ring. And then nucleophilic additions and formation of a cyclic amino acetal. And then deamination resulting in the aromatic indole. So these important points for the reactions of Fischer-Indole synthesis which is happened during the mechanisms. Now you can see the Fischer-Indole synthesis. Phenylhydrazines give 2,3-dimethyl 1-H-indole. Phenylhydrazine in presence of acetone, H plus acidic medium zinc chloride under heating, you will get a 2-methyl 1-indole. Write it down. Synthesis. Bishler-Mollu indole synthesis. Indole synthesis. Synthesis of 2-aryl indole from an alpha bromoacetophenone and excess aniline. You can see the aniline, you can see the ketones, you will get the substituted benzo 2-aryl indole. Now, Matlung synthesis. Intramolecular cyclization of N-phenylamide using a strong base at high temperature. Look at here. To substitute aniline, you will get N-phenylamide, you will get substituted indole. Now, look at here. Matlung synthesis. Ortolidine, it will give N-ortolylformamide, and then you will get this indoles. You have 2-chloro-2-methyl aniline, you will get N-substituted benzamide, you will get 5-chloro-2-phenyl 1-H indole. Now reactions. Electrophilic addition to nitrogen. Indoles like pyrrole are very weak bases. Look at here. 3H indolium cation, most stable, 2H indolium cation. Now, reaction with methyl iodide, 1,2,3,3 tetramethyl 3H indolium compound will form. Now, electrophilic aromatic substitution. EAS of indole favors at third position. Look at here, electrophilic at C3, electrophilic at C2. So, in case of C2, there is a disturbed aromaticity of benzene ring, less favorable. But in case of C3, and that is the favorable. Now, electrophilic aromatic substitution. Nitration, very common. Common nitrating agent cause acid catalyze polymerization, high reactivity of indole. So indole can be nitrated using benzoyl nitrate as a non-acidic nitrating agents. Look at the reaction scheme. This scheme where conversion of indole to 3-nitro-1-H indole. Now electrophilic aromatic substitution, second example, sulfonation. You can see using the pyridine, sulfur trioxide complex is hot in hot pyridine. Then 1H indole 3-sulfonic acid will form. Halogenation, you can see the 3-bromo 1H indole. Now electrophilic aromatic substitution, acylation. Acetylations in the presence of sodium acetate, effort N-acetyl indole. Indole reacts with acetic anhydride, gives 1,3-diacetyl indole predominantly, which upon HL, which aqueous medium hydroxide at the room temperature, gives 3-acetyl indole. Look at N-acetyl indole. And then substituted N-acyl indoles. And then you can see the reactions in 3-diacetyl indole and then further 3-acetyl indole. So the second examples, you need Mannich reactions. Mannich reaction is also important. Reaction with the iminium ion. Indole react with a mixture of formaldehyde and dimethylamine in acetic acid by substitutions and convert into 3-dimethyl aminomethyl indole, gramine. So formaldehyde, dimethylamine, you can see the iminium ion, and then conversions, which is known as Mannich reaction. Now reductions, very important. Now two conditions of the reductions, zinc HCl and lithium ammonia in ethanol. You will get the different products. You can see lithium liquid ammonia reduce the benzene 4,7-dihydroindoles is the main product. Now nucleophilic substitution. You know, N-butyl lithium, presence of ether under 5 degrees Celsius, you will get this. And under two conditions, in presence of CO2H3, you will get the COOH substitution indole, and then if you have the benzophenone, you will get another product. Now, applications. Medicinal uses. Indole alkaloids. Reserpine. Reserpine, antihypertensive of the late 1950s and early 1960s to treat agitated psychotic conditions. Vinca alkaloids, vincristine and vinblastine, anti-cancer agent. Ergot alkaloids, ergometrine to prevent bleeding after childbirth, smooth muscle constrictions effects. Ergometrines, you know, ergotamine used in migraines. Now, you know, the triptans, somatriptans, rizatriptan, naratriptan, zolmitriptan. Treatment of moderate to severe migraines and clusters headaches because of their higher affinity and selectivity for the serotonin 5-HT IB1D receptors. You see somatriptan and rizatriptan. Now, pindolol, non-selective beta blockers used in the treatment of hypertension and angina pectoris. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.